Hello, welcome to this video. It's intended for students in pre-calculus math 40S only, and we're looking at the trigonometry parent functions. Hopefully you've been over this with your teacher in class. This is just meant as a quick sort of overview of what the parent functions look like. We're especially going to worry about sine x and cos x. There are 5 points that you should be able to graph by memory, and then we'll take a quick look at what tan x looks like. We won't worry so much about the detail for tan x. So let's start with y equals sine x. I'm going to make a little table of values here. I've got x and y. Again, you shouldn't be graphing this with a table of values. You should be doing these 5 points I'm going to show you by memory, but I'm just going to show you where they come from. We'll start with an x of 0. Now, it's important to note at this point that x is an angle. I'm going to be working with angles in radians, as that's commonly what you'll be working with in the 40S. So 0 radians, sine at 0 radians is the y-coordinate at 0 radians. The y-coordinate at 0 radians is also 0, so we get a point on the origin here at 0, 0. And then I'm going to go to pi by 2, same as 90 degrees. At pi by 2 radians, my y-coordinate, my sine value is 1, which gives me the point at pi by 2 and 1. At pi, halfway around the circle, my sine value at pi, sine of pi is 0. My y-coordinate at pi is 0. At 3 pi by 2, same as 270 degrees, my sine value at 3 pi by 2, or the y-coordinate at 3 pi by 2, is negative 1. And then at 2 pi, all the way around the circle, because this function is periodic, it repeats, so we're going to get 0 again. That gives you the 5 points you should use as the 5 basic points to start your graph. Now it's important to note this graph is curved, not pointy, so you shouldn't graph it by drawing straight at the points. You should aim somewhere left of this top point, come through, and think nice smooth curve. I'll cheat a little and let the computer do it for me. I'm going to tell it that I'm measuring in radians, so it knows what I'm doing. And when I say OK, you see the graph. Now, as you've taken in class, you know this graph continues to the left and right forever. But these are the 5 points that you should concern yourself with, when you're trying to draw your first version of the parent graph. From those 5 points, you can continue the pattern forever to the left and right. The next parent graph I'm going to look at is cos x. Very similar values, as you're going to see. Just let me clear this graph out of here. Okay, and let me see if I can get these points out of here. If you'll indulge me. Okay, let's take a look at y equals cos x. Again, I'm going to use a table of values to show you where these points come from. But again, you should have these 5 points memorized, ready to go. I'm going to be working in radians again. I'm going to pick the same 5 radian values, 0, pi by 2, pi, 3 pi by 2, and 2 pi. The difference is cos x at 0 is cos of 0, which is the x-coordinate on the unit circle at 0 radians, which is actually 1. So cos x starts, if an infinitely wide graph can start anywhere, on the y-axis we start at 1. At pi by 2, that's my x-coordinate on the unit circle at pi by 2 radians, that is 0. At pi, halfway around the circle, my x-coordinate at pi, cos of pi, is negative 1. And you can probably guess the next 2 values from the pattern, but we'll just get them on here. 3 pi by 2, 270 degrees. My cos value, or my x value at 270 degrees is 0. And then at 2 pi, I'm all the way around the circle. We know it's periodic, so it'll be back to 1. Okay, so there's the 5 points you should have memorized. And again, when you go to draw the graph that connects those points, you want to think smooth curve, not sharp, jagged edges. So again, we'll let the computer do that for us. And I'm going to hit OK. Sorry for these 2 extra dots up here. Okay, and there's your graph of cos x. Same shape, shifted actually pi by 2 to the left. Your teacher will talk more about that from sine x. Okay, nice smooth curve. That's your cos parent graph. The last parent graph I'm going to look at, if I can delete out all these things. Let's get rid of the function. And let's quickly get rid of those points. These 2 mystery points up here. We'll get rid of those. I'm going to actually make my grid a little bigger to look at tan x. It's got a sort of an interesting repeated shape. Okay, so we're going to look at y equals tan x. Now this is a little bit harder to graph because you're going to end up with a lot of vertical asymptotes. When x is 0 radians, tan of 0, remember tan is sine x divided by cos x, or your y value divided by your x value in your unit circle. So when x is 0, when the radians is 0, we get 0 over 1, which is 0, which is this point right here. I'm going to put a different value in here. I'm going to put pi by 4. Because we know on the unit circle in the first quadrant, at pi by 4, this has the coordinates root 2 over 2 for both the x and y value. So when you divide those out, root 2 over 2 divided by itself gives you 1. It's actually an important point on tan at pi by 4, 1. And let's see if I can't quite hit the exact right place here. The graph won't let me. We'll just leave that there for now. Should be right. Pi by 4 is half of pi by 2, so it should be right halfway there. Right, the problem is when we get to pi by 2, y divided by x at pi by 2, if you think of the very top of your unit circle, your y is 1, but your x is 0. You get 1 divided by 0, which is actually undefined. So what we're going to get at pi by 2 is a vertical asymptote. Yeah, I'm going to look at negative pi by 4. Remember, that's negative pi by 4 radians, so we're going to be rotating clockwise instead of counterclockwise in a negative angle rotation, right here. So again, we've got root 2 over 2 for both the x and y values, but the y value is negative, so it's going to give me a tan value of negative 1, which is, it probably won't let me put this right in the middle either, but we'll give it a shot. It's pretty close. So at negative pi by 4, we get negative 1. And at negative pi by 2, we have the same problem. Down here, my x value is 0, and anything divided by 0 again is undefined. So I'm going to get another asymptote there. So it creates a weird little shape that is still periodic and repeats itself. Now you don't have to worry too much about remembering this parent graph. It's going to be asked about less than both sine and cos. Right? But it's important to have some knowledge of this. Every now and again on the provincial exam, they just ask you to graph y equals tan x without transformations. You get this, and you can see these points were a little bit off. Now that I've got a graph there, I can put them right in the right place. So let's do that. Oops. Or at least I'll try to do that. My goodness. Having a hard time. There we go. Right there. Okay. So there's my points at pi by 4, 1, and negative pi by 4, negative 1. right? And I'm going to throw in the vertical asymptotes just for the visual effect that they have. So we have vertical asymptotes at x equals negative 3 pi by 2, at x equals negative pi by 2. We have a vertical asymptote. Basically, every pi, there's a spread of pi between them on the pi by 2's. So 3 pi by 2. The next one would be at x of 5 pi by 2, for example. And I'm just going to quickly make those the same color. So let's make them all red, so we're consistent. This program I'm using is called FX Graph. It's a very handy program, especially if you become a math teacher. You're going to want something like this. So I press OK. Oh, I should have made them dotted. So let's make them dotted. Always make your asymptotes dotted. They are not actual lines on the graph. They are imaginary boundaries. There we go. And that's what the graph of tan x looks like. Quite a bit uglier than sine and cos, but something that you should be aware of where those values come from. Basically, your 5 important points on this graph are the origin, the 2 points at negative pi by 4 and positive pi by 4, and then the asymptotes at pi by 2 and negative pi by 2. Getting that will get you a start, and then you can just repeat that pattern indefinitely as much as you need to finish the graph. And that's the last one, so thanks for watching this video.